This is lecture 4. I'm going to be talking about the basics of MATLAB. If you already know MATLAB, have used MATLAB multiple times, then you can skip this lecture. Just make sure that you follow all the directions on the homework assignments, turning in what files you should, and formatting it the way you should. So I'll talk about some of that in this lecture. Okay, so the basics of MATLAB. How do you get MATLAB? How do you get started with MATLAB? Hopefully most of you are at least familiar with MATLAB. If you are at ETSU, on the ETSU campus, then you can go to the computer labs. I think most of the computer labs have MATLAB on it. Gilbert 205 does, the library does, and from there all you have to do is go to the start menu and Math Software and find MATLAB. From home, you go to the Citrix server. So a lot of you, this is an online class, you're going to be working from home, so you're going to go to the Citrix server. It's going to basically look like this. You're going to go to zen.etsu.edu. You're going to log in with your username, your ETSU username, and your ETSU password. It does not work, at least right now, with my Internet Explorer. It does, however, work with my Google Chrome. Once you log in, you're going to see a screen that looks like this. It has the different programs that are available on the Citrix server. You are welcome to use any of those programs for any of your classes or any research that you're doing. The MATLAB that you're going to want to use is this here. This is an instructional MATLAB version. This is if you're doing research and using MATLAB for research, then this is mainly what that is used for. There's not much difference between these two. Some of the packages may be a little bit different, but not a whole lot is different between these two. But for this course, use this MATLAB version. This should have all the packages that you're going to need. Okay, so I'm going to do a tutorial on MATLAB. I will start it up here just to show you what it's going to look like when you actually start. However, I'm not going to actually, for purposes of recording, the video does not look well trying to record the internet on this video, so I'm actually going to use my own. But I do want to actually just show you what the screen looks like, because my version of MATLAB on my computer looks slightly different. So like you can see, it does take just a little bit to actually get MATLAB up and running. So while we're waiting on that to start, make sure that you have the handout ready, the basics of MATLAB handout. We'll be going through that. Okay, so if you have MATLAB, it should be coming up, should look basically like this if you've started using the Citrix server. The important things to note, and again I'm going to switch to my own version in just a second, but here is your directory. So this is the folder that you're in. You are going to want to change to your Z drive, your student drive. For me, it would be my Q drive. But I would actually change, if it were me doing this, I would actually have a special folder devoted to this class and change to that folder. So that's mainly what I wanted to do on this version of MATLAB on Citrix, and now I'm going to switch over to my own version of MATLAB. Okay, so here is what mine looks like. This is my version of MATLAB, so it will look slightly different, but all of it will be basically about the same. So what you will see over here, this will be if there are any files in that directory that you have created or that you have for the class. There'll be files over here. You'll have variables over here, any variables that you have used over here. You're going to have command history here. And this is going to be your workspace, so I just cleared the screen. This is going to be your workspace. And again, up here is the file that the current folder that you're in. So when you're running a program, you have to be in the folder where the program is located. So I have, for assignment 1, I have programs that I'm going to give you. You have to make sure that the program that you want to run is listed over here. If it's not listed over here in the files, you cannot run it. Okay, so let's get started. Lots of people want to save their work. You can do a diary command and it will save everything that you write in the workspace as well as all the output. So to do a diary command, you need to name the file something. So here I'm just going to call this Intro to MATLAB. and I'm going to save it as a text file so that I can actually edit it later. So now from now on, notice that I have this new folder over here. All of my work, every single command until I get done is going to be in this file. So you can go back and you can edit this file, you can take out anything that didn't quite work, and the stuff that didn't work will be in red, so you'll know which ones didn't work. And you'll want to edit all your files before actually turning them in terms of the homework. So if you forget how to do this, you can always type help diary. It will show how to actually use the command. Now notice this is the typical way, diary file name. I use the functional form where I actually have the file name in quotes. Either way works. You can also click here on .diary and notice that there is a new folder, a new window that comes up, and this has a lot more information on it. Lots of times they give examples. This one does not have examples down here. Let's see if I do help square root. Again, this gives what the square root function is. It takes the square root of the elements of x. If I want to know more, I could type dot square root, and here it actually gives me examples. So examples are always nice to look at. I don't use calculators anymore. I use MATLAB. So MATLAB functions as a calculator. Make sure you want to take -4 squared, you do it properly so it obeys all the standard rules, etc., etc. If you want to know, notice that this is not exactly 0. MATLAB is numerical computation, so you will have numerical error in the way things are calculated. This is what MATLAB says is approximately 0. So if you want to know elementary functions, you can do help lfun. So if you're looking for something that's kind of standard, it would probably be here. Notice now I have a variable over here called ans because I calculated the sine of 2 pi, so it actually stored it over here. But normally, I mean, I could work with this. I could do ants plus ants. I would get about 0, right? Again, so you want to work with variables. And the key thing about variables is that you actually cannot have space. So let's say I want to do test grade and I want to give it the value 85. So test grade equals 85. What that does is it creates a new variable over here. It has the value of 85. If you try to use it, it says it's undefined function. Now in the version of MATLAB which you have on the Citrix server, it's really nice to you. It'll say, did you mean test grade with the underscore? And so that version of MATLAB here definitely would be like, yes, I meant that one. Okay, so let's see, bad grade, we don't want any of these, it's 45. Again, you have a variable over here. I want to get rid of the bad grade. Let's say I want to just clear that variable. So I can do clear, bad grade, no space in your variable names. And again, if you want to capitalize, you can capitalize, but just make sure you know which one you've done when you're trying to call that one again. So I've done clear, bad grade, it's gone, it's no longer over here. I can type who if I wanted to, or who's to see what variables I have, but really all you have to do is look over here. And if there's more variables, you can typically scroll. So like here I could scroll there. If I had more variables, then I normally can scroll up and down as well. Okay, so if I want to clear all the variables, I can do clear all. I have no more variables. Notice I still have this annoying red thing here, and I have a whole bunch of junk that I've already done on my workspace. If I want to get rid of all of this junk and just want to have a nice clean workspace, you can do CLC. It clears the screen. CLC will not clear any variables. So let's say I had x equals 4 and I did CLC. Notice x equals 4 is still here. It just clears the screen. Okay, so formatting. Here is pi. We all know pi has many more digits than that. You might want to see the digits so you can format long. If I don't want to type in pi again, even though it's such a short little word, I can do the up arrow, down arrow, up arrow, and there is pi. There's different types of format. I can do format bank. So if you think about bank, you think about money. So it only has 2 decimals. And again, if you don't know the different formats, help is always where you want to go. All kinds of formats for you to choose from. Okay, so clearing the screen again, we can create vectors. We have row vectors. So here's a row vector. I can create a vector. Let's say I want to step by increments of 2, and I want to go all the way to 7. So y starts at 1, goes to 7 in increments of 2. I can add, if assuming they're properly, all of the dimensions line up, then I can add them. I can take a transpose, so turn a row vector into a column vector. I can do matrices. So here, if I want to do matrices, I have my row, and I separate from my next row with a semicolon. Notice each time you actually see the output. If I don't want to have the output, I can put a semicolon at the end and it suppresses the output. You're going to want to suppress the output. So let's say I have something, line space is something that creates a variable. In this case, it creates a variable, it goes from 1 to 4, and it gives, if I put this 20, it gives me 20 numbers between 1, starting at 1, and going to 4. So if I do that, notice I have a lot of numbers. If I hadn't put that 20 in there, the default is 100. I really don't want to see all of those. So instead, remember the up arrows, your friend, I can hit semicolon and it suppresses the output. Make sure, the thing I think I forgot to mention, if you do multiplication, you have to actually put the times sign. So just be aware of that. Okay, so plotting. Let's say I wanted to plot something and I want to go from 0 to 20 in increments of 0.2. And again, I do not want to see that output, so I'm going to suppress it with a semicolon. And so what I'm going to plot, if you're following along in this worksheet, I'm going to plot what is called the velocity. It's the velocity of a free-falling jumper. So you have gravity involved, you have the mass of the person who is crazy enough to jump, you have the drag coefficient, because there's going to be some drag, and there is a differential equation that can be solved that relates all of these quantities together. And so you have the velocity. If you solve this differential equation, the velocity of the jumper or the free faller is given by this formula. Again, we want to suppress it. And from what we know, obviously just taking into account drag velocity, the mass, and the gravity probably isn't everything that's happening. It's, remember, if the mathematical model that went with this is not exact, it's an approximation. Okay, so now I want to plot T and V. If they were not the same size, you would get an error. So here is what happens to my velocity. My velocity is going to increase as the jumper is going. So this here is time, but I can't tell it's time, can I? So I want to label these axes. You're going to always want to label the axes. I can do an X label, time. My Y label, well, let's just call it velocity. And my title, plot of V versus T, or free falling jumper velocity. Okay, so your figure is going to be hidden somewhere right down here. Got to go back and find it. So I have all of this. Let's say I want to save this, so I can do save as. It's going to save in whatever folder you're working in. Give it a name. So I'm going to give it jumper. There's all kinds of different file formats that you can use. You probably want to save it as a .fig and as something else. The .fig is so that you can actually go back and open it up again in MATLAB and modify it. So if you're actually trying to print this in a report, you'd probably want .eps because it works best in files. .jpeg is what you're going to want to give me whenever you actually do, because you can import JPEGs into your text document or your Word document once you are formatting it. So you're going to want to save as a JPEG. The reason why I always save as a .fig is because I can go back and I can modify it. Okay, so here I have this, and I close it down and I go, oh no, I was supposed to label my axes differently. So which one am I going to open? I'm going to open the .fig. I just double click on it and here it is. So now I can edit using this arrow. I can double click on my axis. Okay, so now I can, let's say I can't see this when I actually put it into the document. I can make it thicker. Maybe I wanted it black. Here maybe I can't see. A lot of times you can't see the axes when you actually put it in a paper. I make it bigger. I can click on each one of these, change the font, so etc., etc. And then I can save it again. Now it's going to save as the .fig because that's what you were modifying. If you want to actually modify the one that you're going to import into the Word document, you probably want to go File, Save As, and let's also change that one. And do you want to replace it? Yes, I do. Okay, so we have our figures. We know how to plot now. Now the biggest thing that we're going to want to know how to do is not have to do all this in the workspace every single time. So if I want to plot this, let's say I change the mass. I don't want to go back and have to tomorrow come back in, type in this T again, this G, change my mass, CD, this V, and do all of this again. So what's easier is if we use files. There's two different files that we're going to work with, script and function. The script file is just like you're working in the workspace. So here, let me kind of close this down just a little bit. Okay, so the script file is just like you're working in the workspace. So I can do 16 minus 4 if I want to. I can do T equals 2, etc. So if I do this, notice here, T is 101 by 1 vector. I'm going to save this file, so I'm going to do File Save As, give it some name, random stuff. It's always going to say MATLAB files with the .m. I click on Save, and so to run it, I can come over here to my workspace. It's called Random Stuff. I can just type Random Stuff, and it runs. Notice now my T is 2. So if I didn't want to change that T, it was in the workspace, well, the script file does it anyway. So let's say I want to take the square root of T. The other way I can do this is I can hit the run button. This actually runs it and gives me all the output. So there's two ways to run it. You can type in the name or you can hit the run button. The other type of file that we're going to talk about is a function file. Function has this standard format. The keyword function is always in the front. You have whatever output. So let's say Y is my output. Let's say I want to, what am I going to do in this file? Let's say I'm going to multiply some number by another number. So I'm going to multiply x by b. Multiply by b. this is going to be the name of my file, the name of my .in file, and the name of my function. These are my inputs, this is my output. So I just do whatever commands I want to in here. So I'm going to take x times b, and I'm going to suppress the output. When I do file save as, it already gives me the name. It knows what the name should be because that's what I'm going to call in MATLAB. So I hit save. What a lot of people want to do is they want to hit run. Oh, run's not a good thing, gets errors, it's not happy. Why isn't it happy? Because it needs x and b. You haven't given it what x and b are. So I can hit the up arrow. Let's put in 8 and 2 and get out 16. Well, let's say I want to go back and I want to have two different things. I want to do y1 and y2. And so I need to change this to y1. Let's say my y2, I want to do x divided by b. Well, again, do not hit the run button. You'll be tempted to. So now, if I do multiply by b, 8, 2, it only gives me 16, but I changed it. It should have two outputs. The problem is over here in the workspace, I didn't give it two output names. So here I can say out1, out2 equals multiply by b 8, 2. And now it gives me both outputs. So if you want to see both outputs, you need to label both outputs here. Otherwise, it only gives you the first one. Okay, so that's a function file. I advise you to go through and look at the examples that are given in the Basics in MATLAB file. And the last thing I should note is if you're done with your diary, you can do diary off. And this will be saved. You can always take this intro matlab.txt, open it up, and I don't think I can open it up from here. Oh, there it is. So look, there's all of our files, everything that we had written in there, and we can save this. And actually what I would do is I would just open this up in, instead of opening it up here, I would have opened this up in the Word document, save it as a Word, and like you would want to get rid, notice how it has all of these things where I did the help diary. You don't want all that stuff when you're trying to turn in things, and you definitely don't want your errors. So here, undefined function or variable test grade, you want to get rid of the errors. So before you turn anything in, you're probably going to want to have a folder devoted just to, for instance, assignment 1, and you're going to want to have all of the files that you need in that folder. You want to edit whatever folder you're going to turn in that has the answers in it, and you're going to zip it all together and turn it in. And I'll talk more about that in the next lecture.